Hello everyone, my name is Parag and welcome you all in my next video. In this video, I'm talking about cement concrete. Yes, basically, why I'm uploading this video on YouTube because of the concrete is really very important parameter in the civil engineering, and we have to know about why the cracks are formed, what are the reasons to formation of the cracks, what are the ingredients of the cement concrete. Okay, so for that, and what are the hydration reaction in concrete. So for this purpose I am uploading this video, so hope you like this, and please don't forget to subscribe my channel. Okay, and here let's start. Normal concrete is made up of this cement, coarse aggregate, fine aggregate and water. As we know that the chemical admixture and the mineral we are normally used in the concrete because to determine to take the more workability, serviceability of the concrete. Okay, if you know about the ready mix concrete, in the ready mix concrete normally they use the admixture to gain the more workability, more durability of the concrete. Next we go for what are the engineering definition we are applying for the concrete. These are the cement plus water which formation of the paste plus sand which form the mortar, and the mortar plus coarse aggregate forms the concrete. Okay, so this is the procedure where the production of concrete can be done, like a material and the process. Material is that means selection and proportion. As we know that the process of batching is known under this selection and the proportionating of the material. Now coming to what is the mixing process of the concrete, that means in the production of the concrete, which procedure is come under it's like a mixing, transportation, placement, compaction and curing. If I am going to compare this process with some example, like first of all we are mixing the sand, cement, coarse aggregate with water, then we are transported by using weighing bucket or whatever else, okay, to the particular construction site. Then we place that concrete. Okay, after that we are compacting the concrete. Okay, then after compaction we are providing the water for the curing to do the rate of heat of hydration process. Okay, now this was the process normally come under the construction, or normally come under the construction of the concrete. Okay, now we are coming still at we did some basic parameter what are the cement concrete. Now from this slides we go for the what are the ingredient of the concrete. Okay, ingredient of concrete like cement, aggregate and water, and admixture also. Admixture is one of the additional ingredient of the concrete which is work for the more durability, more serviceability of the concrete. Okay, so first of all is the cement. Cement is one of the most and costlier ingredient. It is optimizing the use of the cement to achieve the desired properties through the power engineering and mixed design technique is necessary. Affect the cost of the construction. Definitely if the cement is there, the cost of the construction is more. Okay, and there is one of the best disadvantages if there in a cement is that has a negative impact on the environment. Okay, because it liberates the CO2 gas in the environment, so that's why this is one of the very dangerous gas, as we know that. So this is one of the biggest disadvantage of the cement. Still we don't have any addition to the cement. Okay, because we have to use cement because is one of the best binder, okay, which is made from the lime, okay, and silica. So that's why this cement can liberate CO2 gas in the environment. Now the different type of cement are available in a different location, like structure and environment condition. Obviously, because if you go for the construction beneath the sea, so there is a rapid hardening cement heat, okay, more heat liberator than a rapid setting time of the cement. Such a type of cement is required, so that there is a cement which is available in a random manner. So that's why cement is really very costly material and costly ingredient of the concrete. Now we go for some aggregate. As we know that fine aggregate and a coarse aggregate can be normally available in the market, so there is no need about to do some more discussion on the aggregate. Okay, but yes, the aggregate give the volume to the concrete and dimensional stability. This is one of the main advantage of the aggregate. Okay, coming to the water, let me tell you one thing guys, the 38% is really very important factor in the concrete, because if you cross the 38% of the water in a concrete, then it's all of the permeability, it's forms the capillarity action in the concrete, and that tends to the cracks in our concrete. That is one of the major reasons. Okay, if the 38% can be maintained in the concrete, then and only then it is a proven theory that it the 30% can be stored in 30% get consumed in a water, consumed in that concrete. Then and only then the concrete can be getting the proper durability and workability. Okay, it shows the proper durability and workability of the concrete. Okay, now coming to the water required for hydration of the cement used to be restricted to the minimum required for the hydration and workability. When in excess make the concrete porous and the adversely affect the strength and the durability, as we know that. Okay, now we come to admixture. As we know that it is the optional ingredient of the concrete. Okay, so I did not wanted to say more about this, but yes, if you do the mix of the any design in RMC, then this admixture helps a lot. Okay, used to modify some specific property of concrete like setting time, workability, strength and durability. If I am going to talk with the setting time, like if the RMC plant made some concrete of 6 meter cube, and they are going to transport from one place to another place where the 10 kilometer distance is to be there. So at that time, to recover the to make the setting time delay, okay, to all of the delay in the settlement of the concrete, for that admixture can be used. Okay, some of the parameter like setting time, to improve the setting time, to improve the workability, strength and durability, surface hardness. So that's for this reason the admixture can be used in a cement concrete. Now we further talk about the cement concrete, ordinary Portland cement. Here OPC, I'm sorry, I'm mistaken. Okay, so it's a composition and manufacturing process. So what is the composition of the ordinary Portland cement is like calcareous material. We know that the lime and chalk is the calcareous material, argillaceous material, siliceous material which is silica, and gypsum. Okay, there is a manufacturing process like proportioning the raw material which is known as the batching, grinding and mixing, and after burning the calcination in a clean of 1400 to 1500 degrees Celsius. Okay, at that process the cement can be formed. This is what one of the process. Now what are the cement composition? Okay, what are the composition raw material in the ordinary Portland cement? Calcium oxide is consistent, which is named as the CaO, 59 to 64% available in the cement, ordinary Portland cement. Silica oxide, aluminum oxide, ferric oxide and magnesia. These are the standard percentile which are the available in the ordinary Portland cement. After reacting this calcium silicate, when the calcination process start, all the oxide get converted into hydrate, silicate and aluminates. Okay, so on heating, calcination oxide get converted into silicates and aluminates, and the other compound which is formed by the calcination process is like tricalcium aluminate, tricalcium silicate, tricalcium aluminate and tetracalcium aluminum ferrite, which is named as C3S, C2S, C3A and C3A4, where these are the formulae. It is very simple to remember, like calcium and silica, CaO1 and SiO2. Okay, tricalcium 3 SiO2 CaO2 into SiO2. Okay, where these are the standard percentile available in the ordinary Portland cement. Okay, after that, this is one of the main parameter, one of the main difference between tricalcium silicate and dicalcium silicate. Tricalcium silicate helps to impart the starting strength, okay, up to the 7 days. It contribute to gain the starting strength in 7 days. After the remaining strength which is gained by this C2S. Okay, silicate reacts with water and produce a gel called as calcium silicate gel. This gel is initially very weak, but and very porous, but as the times spent, after that it getting more stronger and less porous. Okay, there is a exothermic reaction formed in the cement. Only because of that there is a lot of heat can be generated. Okay, only because of that we are providing the gunny bag to sustain the water, to make the water can be locked during the slab construction or during the column construction. Okay, that's why we are providing the gunny bag to proper the heat of hydration process. Okay, now here is a reaction where we can find out how much amount of the energy can be produced during the addition of the water in a tricalcium silicate and the dicalcium silicate, where this reaction is called as a reaction of hydration. Okay, when tricalcium silicate react with the hydrogen, okay, then the formation of this C3H2H3 plus, this is called as a gel. Okay, calcium silicate hydrate gel, then calcium hydrate, then 114 kilojoule per mole. This is one of the important parameter that is a meaning that when the reaction of the tricalcium silicate they held with the water At that point, the 114 kilojoule per mole the heat is liberated. That means, and if I compare this reaction with dicalcium silicate, that's when tricalcium silicate react with water. If we compare with the dicalcium silicate react with the water, we can see that the 43 kilojoule per mole is liberated. That means a very less amount of energy has been liberated. So from this observation, we can conclude that this 114 kilojoule is formed at the starting 7 days. Okay, this help to gain the strength in the starting 7 days and liberate 114 kilojoule per mole, and after that rest of that means for a total period the 43 kilojoule per mole, that means dicalcium silicate helps to gain the strength after the 7 days. Okay, now here the CSH, the notation, what are they denoting. Okay, now coming to the reaction of hydration, the tricalcium silicate consists superior to tricalcium silicate and dicalcium silicate because produces superior and larger quantity of C3H gel. Okay, we are very common as we form in a above reaction, we form this observation. Now tricalcium silicate produce 61% of gel and 39% of carbon hydroxide CH. Okay, you can see here what are the percentage I have provided over here. Okay, after that yes, one of the main reason is that less heat means more durable concrete with less crack. Okay, so this is what the important parameter. We know why the cracks form. This is one of the important reason. Only heat is to be there. Okay, but not only heat, the water content is also one of the parameter which tends to impart the cracks. If the water parameter exceed more than 38%, definitely cracks will be there. If the water content is less than the 38%, there will be no chances. If the 38%, then there will be no chances to get the cracks in a concrete. Because I'm not talking from my side, because what I searched and what I got from the another side. So the 38% is a common factor which is used, which have to maintain in the concrete. Okay, to make the concrete more durable and workable, to get the consistency from the concrete. After coming toward the another reaction of the hydration, about the 15% of the water get filled with the gel porous, and about 23% of the water is required for the chemical reaction. Any water in excess 38% cause the capillary formation, increase the permeability of the concrete. If only 38% of water is used, concrete will be more compact, stronger and more durable. The extent of a reaction of cement and water is called the degree of hydration. Okay, you can define this degree of hydration like this. After that, the reaction of hydration is the one of the most important parameter in all this video. Like a degree of the hydration is measured indirectly by measuring the heat involved. Approximately 50% of the total heat involved occur during the first 3 days of hydration. In the total volume of paste, 100%, 50 to 60 CHS carbon silicate hydroxide gel, 20 to 25% CH, and the rest of water will be porous. Okay, and tricalcium silicate is quicker in reacting with the water compared to the dicalcium silicate. Initially strength up to the 7 days is mainly because of the tricalcium silicate, as I already told you, and thereafter C2S. Okay, so this is all about the hydration reaction and the one of the ingredient of the ordinary Portland cement and what is a concrete exactly. Okay, so thank you for watching my video. I think with the help of this video you can get some answer why the cracks form in a concrete and what are the reaction, which is one of the helpful to know the how much amount of heat can be liberated during the first 7 days and after rest of the days. So I hope that you guys like my video. Please don't forget to subscribe my channel, and please like my video. Okay, so thank you and bye bye.